Every junior developer loves Singleton. Every senior developer avoids it. Why? Because it creates hidden dependencies, makes testing a nightmare, and turns your code into a tightly coupled mess. Let me show you the pattern, the problems, and the better alternative. Singleton pattern, and why to avoid it. Low-level design, day 10. The Singleton pattern ensures a class has exactly one instance and provides a global point of access to it. Here is the classic implementation in Go. You define a struct, say app_config, with a private constructor. Then a package-level variable holds the single instance. The getInstance function checks if the instance is nil. If it is, it creates a new one. If it already exists, it returns the existing one. In Go specifically, you use sync.once to make this thread safe. The do method guarantees the initialization function runs exactly once, even if 100 Go routines call getInstance simultaneously. In Java, the classic approach uses a private constructor so nobody can call new, a private static instance variable, and a public static getInstance method with synchronized or double-checked locking. The pattern looks elegant. One instance, global access, lazy initialization. Singleton seems useful for several common scenarios. Database connection pool. You want exactly one pool shared across your application, not multiple pools competing for connections. Logger. One global logger writing to the same file or service, not scattered logger instances with different configurations. Configuration. One config object loaded from environment variables or a config file, shared everywhere. Thread pool. One shared pool managing worker threads efficiently. These all sound like legitimate reasons to use Singleton, and they are real constraints. You do want one connection pool. You do want one logger. The trap is not the constraint of having one instance. The trap is how Singleton achieves it. Global mutable state accessed from anywhere without any explicit dependency declaration. The one instance constraint is valid. The Singleton pattern's way of enforcing it is not. Here are the 5 critical problems with Singleton. First, hidden dependencies. When a function calls getInstance inside its body, there is no way to know it depends on that Singleton without reading the implementation. The function signature lies. It says it takes 2 parameters, but secretly it depends on global state. You cannot understand the function's behavior from its signature alone. Second, testing nightmare. You cannot replace the Singleton with a mock or stub. Unit tests that should be isolated now share mutable state. Test A modifies the Singleton, and test B sees those changes. Your tests become order-dependent and flaky. Third, tight coupling. Every piece of code that calls getInstance is coupled to the concrete Singleton class. You cannot swap implementations. You cannot use a different database for staging versus production without changing every call site. Fourth, concurrency issues. Lazy initialization creates race conditions. 2 threads check if instance is nil at the same time, both see nil, both create instances. You need synchronization, which adds complexity and potential deadlocks. Go's sync.once helps, but you still have shared mutable state being accessed from multiple Go routines. Fifth, it violates the single responsibility principle. The class manages its own lifecycle, controls access to itself, and does its actual business logic. That is at least 3 responsibilities in one class. The better alternative is dependency injection. Compare the 2 approaches. With Singleton, your order service calls database.getInstance inside its methods. The dependency is hidden. To test it, you need the real database. To change the database, you change every file that calls getInstance. With dependency injection, the order service constructor takes a database interface as a parameter. The dependency is visible in the signature. To test it, pass a mock that implements the interface. To change the database, pass a different implementation. Same one instance constraint, completely different approach. In your main function or application bootstrap, you create the single database instance once. Then you pass it explicitly to every service that needs it. New order service takes the database. New user service takes the database. New payment service takes the database. They all share the same instance. One pool, one connection. But the dependency is explicit. Functions declare what they need. Tests can substitute fakes. Swapping implementations requires changing one line in main, not 100 files. Dependency injection gives you everything Singleton promises: single instance, shared access, without any of the problems. Hidden dependencies become explicit. Testing becomes trivial. Is Singleton ever acceptable? In rare cases, yes. Hardware access where there is physically one resource, a printer spooler managing one physical printer, a GPU context managing one graphics card. Truly global, immutable configuration that is loaded once at startup and never changes. No mutations, no side effects, a simple read-only config struct. Caching layers where the cache itself has no business logic and serves as a pure lookup optimization. Even in these cases, dependency injection is usually the better approach. Create the single instance in main and pass it explicitly. The constraint of one instance is enforced by how you wire your application, not by the class itself. Frameworks like Go's UberFX, Java's Spring, and Python's dependency injector handle this elegantly. You declare that a dependency is a singleton in the container configuration, and the framework ensures one instance is created and shared. The class itself has no knowledge of being a singleton. It is just a normal class with a normal constructor. In interviews, here is the strategy. When asked to implement singleton, show you know the pattern. Implement it correctly with thread safety. Then immediately explain why you would avoid it in production. This shows depth. Common interview scenarios: implement a thread-safe singleton in your language. In Go, use sync.once. In Java, use the enum approach, which is the simplest thread-safe singleton. In Python, use a module-level instance, since Python modules are imported once. Explain double-checked locking. First, check without lock for performance. Acquire lock. Second, check to prevent duplicate creation. Create instance. This avoids synchronization on every call after initialization. When asked about design choices, say you prefer dependency injection over singleton for testability and loose coupling. Mention that the one instance constraint should be enforced by the composition root, your main function or DI container, not by the class itself, and know the relationship to other patterns. Singleton is often used with factory to provide a global factory. Abstract factory and builder sometimes use singleton for their concrete factories. But in modern code, dependency injection replaces all of these use cases for managing instance lifecycle. 5 things to remember. Singleton ensures one instance with global access, but creates hidden dependencies that make code hard to understand and maintain. The 5 problems are hidden dependencies, testing nightmare, tight coupling, concurrency issues, and SRP violation. Every one of these is solved by dependency injection. Dependency injection gives you the same one instance guarantee while keeping dependencies explicit, testable, and loosely coupled. Create in main, pass everywhere. Singleton is only acceptable for hardware access, immutable config, or pure caching. And even then, DI is usually better. In interviews, implement singleton correctly, then explain why DI is the production choice. This shows you understand both the pattern and its limitations.